Assalamualaikum warahmatullahi wabarakatuh, and good day everyone. Okay, I'm Mrs. Sadovia. Okay, so for today I will cover numerical method. So for the numerical method, I will cover Gaussian elimination method, Doolittle method, crowd method, and then fixed point iteration method, and the last one is a neutral absent method. Okay, so for this chapter altogether they have 5 methods. Okay, so right now I'll just focus on the Gaussian elimination method. Okay, so before we go to the question, so I will show you the formula. Okay, so you can understand the pattern of the Gaussian elimination method. Okay, so first of all, when you have a question, so we will convert into the matrices. Okay, so we will split into the matrix A, and then matrix X, and then matrix B. Okay, so for the matrix X, depends on the question. So if your question is X, Y, Z, so you write X, Y, Z. If your question gives you X1, X2, X3, so you write X1, X2, X3, and so on. Okay, so the first order transformation, we will change A21 and A31 into 0. Okay, I repeat, for the first order transformation, we will change A21 and A31 into 0. Okay, and then for the second order transformation, we will change A32 into 0. Why we have to do that? Okay, so actually for the numerical method, we want to find the root. Okay, for this case, we want to find the root of x1, x2, and x3. So for this one, okay, so we can find the x3 first. Okay, then we continue to find the x2, and then the last one is x1. Okay, so if you do first order transformation and then you get 2, 0 in any other row, okay, so no need to apply second order transformation. Okay, maybe later I will show you when we don't need to apply second order transformation. Okay, alright, so we look at the pattern first. Okay, for the first order transformation, okay, we will change the number, the second row and in the third row. Okay, so for the A21, okay, the pattern is A21 minus A11 times the number itself, okay, times A21 over A11. Okay, I repeat, A21 minus a number on the top of A21, which is A11, and then times with the number itself, which is A21 over A11. Alright, okay, so when we do a multiplication, A21 over A11, okay, you can look here for the second row, it is same. A21 over A11, A21 over A11, A21 over A11, and the last one also, we follow the first one. Okay, so this is the formula that you have to follow. Okay, so for the A22, okay, same like before, we will deduct the number on the top of the number. Okay, so A22 minus A12 times A21 over A11. Okay, that I mentioned before, the multiplication, we just follow the number 1. Okay, so for the third one, A23 equal to, okay, A23 minus A13 times A21 over A11. Okay, for the last one, B2, okay, same like before, so B2 minus B1 times A21 over A11. Okay, so for the multiplication is same from the first one, so we just follow until B2. Okay, how about the third row? Okay, for the third row, okay, we have to minus also. Okay, but it is the first order transformation. Okay, please take note, if first order transformation, we will deduct the first row. First order transformation, first row. Okay, so I start with A31, so A31 minus A11, and then take back the number itself. Okay, A31 over A11. Okay, I continue. A32. Okay, so A32 minus A12. Okay, times. Okay, we follow the number 1. Okay, which is A31 over A11. Okay, for the third one, A33 minus A13 times. Okay, we take back A31 over A11. Okay, the last one for B3, B3 minus B1, okay, times A31 over A11. Okay, so done with the first order transformation. Okay, we want to change the second row and the third row, and then we have to deduct with the first row because this is the first order transformation. Okay, after you apply the first order transformation, okay, we will copy back in the matrix A, x equal to B. So we have a new number for the second row and third row. Okay, when you're done with the copy and paste the new number, okay, so we apply the second order transformation. Okay, for the second order transformation, we just focus on the third row. It is different with the first order transformation. First order transformation, we will change the number in the second row and the third row. Okay, for the second order transformation, we will focus to change number in third row only. Okay, so we start with the A32. Okay, look at here, A32, and then we have to minus with the second row because this is second order transformation. If first order transformation, we will deduct with the first row. Okay, if the second order transformation, we will deduct with the second row. So it is a tips if you're confused. Okay, because in the final, it is not given all this. Okay, so you have to know and understand the pattern so you can do easily. Okay, so I start A32. Okay, A32 equal to, okay, A32 minus A22, and then we have to time the number itself. So A32 over A22, and then the multiplication. Okay, we just follow for the second and the third one. Okay, so I continue. A33 equal to A33 minus A23, and then we times with the A32 over A22. Okay, so for the last one, B3. Okay, so B3 minus B2, and then we times with the A32 over A22. Okay, so after we don't apply second order transformation, okay, we do back in matrix A, x equal to B. So when we apply the second order and first and second order transformation, okay, so you can get this 3-0 in your matrices. Okay, so this is the formula that you have to know. Okay, when you do more exercise, automatic, you will memorize and understand and do this method easily. Okay, so we do the example, and I will show you how to solve by using Gaussian elimination method to solve this equation. Okay, the equation given is x plus 3y plus 3z equal to 4, and then 2x minus 3y minus 2z equal to 2, and then the last equation is 3x plus y plus 2z equal to 5. Okay, so we try to solve this equation by using the Gaussian elimination method. Okay, so first of all, we have to do into the matrices, which is Ax equal to B. Okay, for the matrix X, okay, we just take a number here, so 1, 3, 3. Okay, for the second row is 2, negative 3, negative 2. Okay, the last equation is 3, 1, 2. Okay, so this is the matrix A. How about the matrix X? Okay, for the matrix X, we just take a variable in the equation, okay, which is x, y, z. Okay, how about the matrix B? Okay, for the matrix B, okay, we just take a number after equal sign, okay, which is 4, 2, 5. Okay, so this is the matrix A. This is a matrix X. This one is a matrix B. Okay, so we want to apply first order transformation. Okay, so before we start with the first order transformation, okay, I will highlight here. Okay, if your question is mixed up the variable, for example, y plus 3x plus 2z. Okay, so you have to arrange, okay, in the correct order. So x, y, and z. Okay, I repeat. If your question, the variable is mixed up, okay, for example, it starts with y, okay, for example, y plus 3x plus 2z. So you have to arrange first in the correct order. So you have to know x in the first place, and then followed by y, and then followed by z. Okay, so I start with the first order transformation. Okay, for the second row. Okay, so I want to change this number in the second row. Okay, so I start with A21 first. Okay, A21, the number is 2 minus number on the top, so 1. Okay, times, we have to take the number back. Okay, which is 2 over 1. Okay, and then we have to apply this one first. Okay, it means you have to calculate the multiplication and division first, and then after that you can minus these two answers. Alright. Okay, so for example here I will get 0. 2 minus 1 times 2 over 1. So I get 0. Okay, and then I continue with A22 here. Okay, so A22, negative 3 minus number on the top, okay, which is 3. Okay, for the multiplication, I just take from the A21, which is 2 over 1. Okay, so you can use a calculator. So negative 3 minus 3 times 2 over 1. So I got here is negative 9. Okay, for the A23, okay, I continue here. Negative 2 minus 3 times, I take back 2 over 1. Okay, so over here is negative 2. So over here is negative 6. So I will get negative 8. Okay, so and then after A23, is a B2. Okay, so for the B2, 2 minus 4. Okay, so I will chance with 2 over 1. So 2 minus 8. So I get here is negative C. Okay, so this is the second row. So I will continue with the third row because I'm out of space. So I just do in here first. A21 is 0. A22 equal to negative 9. A23 equal to negative 8. And then B2 equal to negative 6. Okay, so I have to erase first because I'm out of space. Okay, so I continue with the third row. Okay, so for the third row, okay, so I start with A31. Okay, A31. Okay, the number in the elements A31 is 3. Okay, so I have to minus 2 or 1, guys. Okay, 2 or 1. Okay, the answer is because we apply first order transformation, so we have to minus number in the first row. Okay, which is I have to minus 3 minus 1 times, I take back the number 3 over 1. So over here will be 0. Okay, for the E32, okay, here 1 minus 3 times 3 over 1. Okay, so 1 minus 9, so I get negative 8. Okay, for the calculation, you can use a calculator. Okay, to avoid we do a mistake. Okay, so I continue E33. Okay, it is here 2 minus 3 times 3 over 1. Okay, I repeat, for the multiplication, it's same from 1. Okay, so 2 minus 3 times 3 over 1. So I will get negative 7. Okay, the last one is B3. Okay, B3 is 5. So I have to minus with 4. Okay, I times with 3 over 1. Okay, 5 minus 4 times 3. So I will get negative 7. Okay, so when we get all this, okay, so we have to do matrix AX equal to B again with the new number. Okay, so I erase this. Okay, so for the first row, I did not change anything, so I just copy and paste 1, 3, 3. And then for the matrix X, okay, they have no changes, so I just copy and paste. And then for the matrix B, okay, for the first row, okay, it doesn't change. Okay, so I will write the second and the third row, a new element. Okay, so for the second row, I start with A21, which is 0. A22 is negative 9. Okay, A23 is negative 8. Okay, B2 is negative 6. Okay, so this is the number that we already calculate. Okay, how about the third row? Okay, third row, A31 is 0. Okay, A32 is negative 8. Okay, A33 is negative 7. Okay, for the B3 is negative 7. Okay, so we're done with the first order transformation. So after this, I will continue with the second order transformation. Okay, you all good? Okay, so if you didn't memorize the formula yet, you can refer the note, okay, that I upload in the Teams. Firstly, I already say if you have 0, 0 in any row, you don't have to apply the second order transformation. Okay, for example, in your calculation, for example, you get 8230. Okay, so for this case, you already have 2 0, so you can get the y first, and then you can get the z, the next one, and then the last one you can get x. Okay, so this is the example. Okay, if you have a 2 0 in any row. So for the conclusion, if you have 2 0 in any row, so you don't have to do a second order transformation. Okay, so I start with the second order transformation. Okay, so I repeat, I have to do the second order transformation because I want another 0 in the third row. Okay, so for the second order transformation, I will start with the A32. Okay, so for the A32, negative 8 minus, okay, because this is the second order transformation, so I have to deduct with the second row, which is negative 9. Okay, then I have to multiply, okay, with the number itself, okay, which is negative 8 over negative 9. Okay, so when I calculate, I will get 0 because I can cancel this one and this one. So negative 8 minus negative 8, so I get 0. Okay, so I continue with the A33. Okay, so for the A33, which is negative 7, okay, I minus with negative 8. Okay, so I chance with the same one with the previous, so negative 8 over negative 9 equal to, okay, so for this one I have to use a calculator. Okay, so I calculate this one first. Okay, so I got here is 1 over 9. Okay. Okay, so I done with the A3 to A33. Okay, so for the last one is B3. Okay, so for the B3 is negative 7 minus negative 6. Okay, so I have to multiply with negative 8 over negative 9. Okay, the calculator also. Okay, so negative 7 minus negative 6 times negative 8 over negative 9. Okay, so I got here is negative 5 over 3. Did you see this? Okay. Okay, so I done with the first order and the second order transformation. So what I have to do next, okay, I will write again the ax equal to b, but I just change the number in the third row only. Okay. Okay. So I can copy paste the first row and the second row first. Okay, for the matrix X, it's just a variable, so I do not change anything, so I can just copy and paste. Okay, and then for the matrix B is a 4 and -6. I can copy. Okay, as you know, for the second order transformation, okay, I change the number in A3 to A33 and B3. Okay, for the A31, okay, it is 0. So I can write first. Okay, so I can write the new number. Okay, for the A32 is 0. For the A33 is 1/9. Okay, for the B3 is -5/3. Okay, so when we get the 3 number of 0, so it makes us easier to find a root of x, y, and z. Okay, so I start. Okay, for the tips, we will start with the row with the most number 0. Okay, for this case, I will start with the third row. Okay, so right now we have to multiply this matrix with this matrix. Okay, so we will apply row times column. Okay, so how to multiply these two matrices? So 0 times x plus 0 times y, okay, plus 1/9 times z. Okay, to make you not confused, so I just write on the top of the matrix, so x, y, z. Actually, it is same. Okay, if you understand the concept of the multiplication of two matrices, it is good. Okay, if you want to avoid you confused, so you can do like me. So I just put x, y, z on the top of the matrix A. Okay, so I start with the third row. Okay, 0 times x 0 plus 0 times y 0 plus 1/9 times z. Okay, equal to -5/3. So your z equal to, okay, take your calculator. Okay, -5/3 we divide with 1/9. Okay, so I got -15 here. Okay, so this is the z. Okay, I continue with the second row, so I want to get y. Okay, so we repeat the same step. 0 times x is 0, okay, and then -9y. Okay, plus -8 times z. So -8z equal to -6. Okay, so before we calculate, okay, look at here. Okay, this is the variable z. Okay, so we already have the value of z here. So you have to substitute first. Okay, so -9y minus 8. And then z, we substitute with -15. Okay, -6. So over here is -9y. Okay, so I move -8 times -15. So I got here okay, I got here 20. Okay, so negative 6 minus negative 20. So I got negative 1, 2, 6. So how about y? Okay, so I got positive 14 here. Okay, so we already have z, we have y. Okay, how about x? Okay, so for the x, we start with the first row. So 1 times x, which is x, plus 3 times y is 3y, plus 3 times z, so it will be 3z. Okay, please make sure you always use a plus here. Okay, so this one I use minus because they have a negative number here. Okay, negative 9 plus negative 8 times x. So plus with negative will be minus here. Okay, so I continue back the first row. So x plus 3y plus 3z equal to 4. So okay, x plus 3y. So we already have the number of y. So I substitute here 40 plus 3z. Okay, negative 15 equal to 4. Okay, so x equal to, okay, so I get here is negative 3. So when I move, I get 4 plus 3. So I get 7. So x equals to 7, y equal to 14, z equal to negative 15. Okay, how to know our answer is correct? Okay, so the first way, you can use the calculator. You can use a mode EQN, and then you put all the number in the calculator. Okay, the second way to check your answer correct or not, okay, you substitute the value of x, y and z into the equation. Okay, if you get the answer, so your answer is correct. Okay, so it's done with the Gaussian elimination method. So for the conclusion, okay, first of all, you will convert into the matrices first. So matrix A, matrix X, matrix B. Okay, then we will apply the first order transformation for the second row and the third row. Okay, so when we do a matrix A, X equal to B, and then we check they have no 2, 0 in any row, so we have to apply second order transformation. Okay, after we apply the second order transformation, we do again matrix A, X equal to B, and then after that, okay, you can directly find the number of Z, Y and X. Okay, so this is the Gaussian elimination method. I think the method is not very hard. If you do many exercise, so you can do well. Okay, so after this I will teach you how solve the equation by using Doolittle and the Brown method. Okay, anyway, thank you so much for watching. Okay, bye.